Hello dear students, good morning. Today we are going to discuss magnetic effects in electric current. So already we discussed that Easted, in the very first class we discussed that Easted discovered there is a relation between magnetism and electricity, and we were discussing these relations throughout the chapter, isn't it? At last we reached at electric motor, and from the electric effects we produced by the help of magnetic field we produced even an electric motor. So there we reached it. Then Michael Faraday is the father of electricity. He started to think, if we can produce magnetic field from electricity, why can't we produce electricity from magnetic field? So he thought on this. For many days he was thinking this thing, and he started working on this project, his thoughts, from 1925, and after 6 years, 1931, desperately, he was very sad, he can't find any way to prove that a magnetic field produces electricity. There was no way. So he was doing this experiment with some of the coils, magnets, etc. Coils means, you know, if a wire is wound on a cylindrical, like a solenoid, it is called coil. So if a wire is wounded just in a circular manner, it's called coil. So he was doing this experiment with coil galvanometer. Galvanometer is an instrument to show the direction of current. It will show either right or left. So by looking into the galvanometer, we can understand its needle will be pointed towards right or left. By looking into that, we can understand where is the current flow, what is the direction of current flow. If it is moving into the left side, that means the current is flowing in this direction. If it is moving to the right side, it is my right here, the current is moving in this direction. So it shows the direction of current flow. So he was doing this experiment with the coil, magnet and galvanometer, but he can't find any relation. So by 6 years he was fed up. He thought we can stop this experiment. With the desperation, he threw the magnet into the coil placed in the table. But suddenly what happens? As the magnet enters into the coil, on the moment galvanometer shows a deflection. So it was like this. A coil was here, and into the coil a galvanometer that was connected into this coil. So a galvanometer consists of a needle, and its needle suddenly shows a deflection. From zero portion it shows a deflection when he throws the magnet into the coil. So that proves the presence of current. If galvanometer shows any deflection, that means there is a presence of current. So from magnetism, he proved the presence of current. Then he do many experiments based on this. Whatever, first of all, he placed the magnet here. There was no movement in the galvanometer. But whenever he moves the magnet, there is a deflection in the galvanometer. If you bring the magnet too close, there is a deflection in the right side, and if he is bringing it back to the original portion, the galvanometer shows a deflection to the left side also. So to the right and left, it shows deflection as it is moving towards or away from the magnet respectively. That is, if it is moving towards the coil, it shows a deflection to the right, and if the magnet is moving away from the coil, it shows a deflection to the left side. So he was so happy so that he can prove the presence of, or the fact that magnetism can produce electricity, and it was a big boon to our industry. From that, we are nowadays what we are experiencing this current, electricity, KCB providing us electricity. That is all based on this thing. Now see, so from this he find that whenever the magnet is in stationary condition, there is no production of current. But whenever the magnet is moving towards or away from the coil, there is a presence of current. That is, galvanometer shows deflection. Even if the magnet is placed here at rest, in stationary condition, there is no presence, there is not any presence of current. Galvanometer does not show any deflection. But if he moves the magnet a little bit, there is a presence of current and it shows deflection. So he come to a conclusion that if the magnet and coil is at rest or in stationary condition, there is no creation of electric current in the coil. But if the coil or magnet moves relatively means if the magnet is stationary here, if the coil moves here, if you move the coil towards or away from the magnet also, there is a presence of current. Or if the coil is stationary and if you are moving magnet towards or away from the coil, then also there is a presence of current. So whenever we move either magnet or coil, if you move either magnet or coil, there is a presence of electric current. And he also observed that whenever we increase the speed of this motion, if you are increasing the speed of the motion, if you are taking this in and out very fastly, what happens? The galvanometer shows deflection out both ways very fastly. That means more current flows at that time. So if you are increasing the speed, that means more current will flow through the coil. If you are making it stationary, no current flows in the circuit. And if you are moving either coil or magnet relative to each other, then there is a production of electric current. So that was the observation by Michael Faraday, and these observations was done on 17th October 1931. His observation was made on this date, 17th October 1931. And it was once such a big discovery in the field of science, big boon to the industry or scientific industry itself, because based on this many machines, nowadays we are using many machines and they are all working on this principle. So that's all about the electromagnetic induction topic. So the current that we got from this by the magnetic effects, that is called electromagnetic induction, that we will discuss in the next class. Today just go through the Faraday's experiment. So Faraday's experiment consists of a coil, a magnet which obviously consists of a north and south pole, and a galvanometer. What is galvanometer? Galvanometer is a machine to measure the direction, to show us the direction of current flow, to show us the presence of current flow, and a coil. So this was the experimental setup. From that he come to the conclusion that whenever there is a motion or either of coil or this magnet, there is a presence of electric current, and whenever both are in stationary condition, there is no production of electric current. And if we increase the speed of motion between the coil and magnet, more current flows through the circuit. This was 3 observation by Michael Faraday. Hope this section is clear. It's a very big topic, that's why I cut it here. In the next class we will be discussing the next half of this portion, that is electromagnetic induction. That part we will be discussing in the next class. Before going to that class, you have to know what is magnetic flux. We already discussed the magnetic field, isn't it? So the total number of lines in a magnetic field is called magnetic flux. Total number of lines in a magnetic field. You know what is magnetic field lines? So the number of magnetic field lines is called flux. That will be useful in the next video. Thank you for watching. Have a nice day.